Hi everybody, I'm Steve. In this video we're going to take this p5play project that has plain blocks and make it so you can replace those blocks with ones that have custom patterns and textures. That's how I made this art project, which sold as an NFT on FXHash. In my last video I introduced the p5play library and coded this project. If you haven't seen that video, I strongly suggest you watch that video first before watching this one. Now, before we get started with what I'm going to present to you today, I do want to point out that there is a draw function in p5play, and I did try this out. If all you want to do is replace the sprites with an image that you upload, you can do that. And here is the blocks replaced with these eyes that I uploaded. Now, you notice it is a little bit laggy. There's some frame stuttering. But I'm a generative artist and I wanted to replace all the blocks with custom patterns. That's what we're going to do in this video. And when I tried to do that with this method, it wanted to redraw patterns over and over again. And that just made my computer freeze. So that wasn't an option. Okay, let's get started. So here's the code that I created last time. The first thing we need to do is to duplicate this. So we'll do that. And then we are going to be creating an array of canvases. Let's do this. And we're going to be replacing all of the sprite blocks with our own blocks from buffer canvases. So we're going to need a counter in here. Let's do count equals 0. It starts at 0. And then remember with the walls, we created a group for those. We didn't do that for the sprites last time, but now we're going to create a group to help us with this. So let's call it blocks equals new group. And since we're doing that, let's go to the place where we created the sprites, scene 1 and scene 2, and instead of new sprite we're going to do new blocks.sprite and new blocks.sprite down here. And then another thing with these scenes, I hard keyed this 50 width and 25 height. I want to change that and make that a variable. So let's do width for the width. And I'm going to make that a factor of the width of the screen. So 0.035 is what I came up with for the size of the block. And then we'll do the height a factor of the width. So we'll do width times 1.7. And now we can replace this with WID and this one with HGT. And then let's copy this for the next scene also. We'll put that here and replace this with WID and replace this one with HGT. There's one other thing. Since we're going to be replacing all of the sprites, every time we make a new sprite, we're going to call the replace sprite function that we're going to be creating so that every time we create a sprite, we also create a buffer canvas to replace that sprite. So let's call a replace sprite function, and we'll do that for the other scene as well. This is going to be within this for loop, like the last thing we do in that for loop. And make sure that this one is within that for loop too, and it is. So now we need a replace sprite function. Let's do that maybe here. And we'll do function replace sprite. So you remember I said we're going to create an array of canvases. So the first canvas number, this is going to be using that counter that we started. And we're going to say canvas count equals create graphics. And the width and height of this create graphics is going to be that width and HGT from the scene. So we've created our buffer canvas. Now we need to do some things with that buffer canvas. Canv.count. Let's do rect mode center for our rectangle. We also want to be in color mode, HSB. And then we're going to grab a color. We had our make color function to grab a color. We're going to use that color that we just grabbed to fill. So HSB. So let's do can count dot rect, and the rectangle is going to be located, since we've got rect mode center, it'll be located at width divided by 2, height divided by 2, and the size of that rectangle is going to be the width and the height. Now you might be saying, why am I creating a rectangle if the buffer canvas is the same size as that rectangle? Well, I might be creating a circle or a triangle within that buffer canvas, and just for consistency, I want to create a rectangle that's going to be within the buffer canvas. So then, just for now, let's just do one thing to the rectangle to add something so that we know that we're replacing the regular sprite with our custom sprite. So let's just put a circle in the middle of the rectangle. So we'll do width divided by 2, height divided by 2, and we'll do width times 0.5. So that should place a circle right in the center. So then the last thing we need to do in this replace sprite is we need to do count plus plus, so that the next time we call this function, the first time we call the function, it'll be 0 canvas, and then the next time we call this function, it'll be creating canvas number 1, and then 2, etc. So we've got our canvas created to replace the sprite, but now we need to place our sprite. So we need to go to the draw function for that, and after the background, we're going to be placing all of our sprites. We need to go through the entire array of canvases to replace every sprite that's on the screen with all of these canvases. The sprite array is going to be mirrored with the canvas array. So let's do a for loop. We'll say z equals 0, and the z, we're going to go through the blocks dot length, because we're going to go through the array until we get to the last block in the array. And we're going to do z++ so that we go through the entire array. So what are we going to do within the for loop? So first we're going to be translating to an XY position, and then we have to rotate, because remember, these blocks are falling and bouncing around, and so the blocks might be at any kind of angle at any one time, and we want to capture that information. You see, the blocks array that was created with p5play contains a bunch of information. It contains the X position, the Y position, the rotation, the width of that block, the height of that block, and we're going to pull that information out of the array to use it in order to place our canvas in the right position and at the right angle. So the first thing we need to do, since we're translating, is we need to push. Then we're going to translate. And where are we translating to? We're translating to the blocks array, the z position, which is the number in our for loop, and dot x. So that's the x position of the whatever block we're on. And then we're going to grab the y position, which is the same sort of thing, blocks z dot y, and that's our translate. Now we've got to rotate. So again, we're going to pull information from the blocks z dot. This time we're going to pull the rotation, which is like this. Now we've translated, we've rotated, we have to place our image, our canvas that we created. So we're using image, and we place our canvas. So notice I'm using our canvas array this time, but still using the z. Now, how are we going to place this? We don't want to just place it at 0, 0, because remember, with p5play, the block, the XY position of the block is in the center of the block. So if we place an image at 0, 0, that top left of that image is going to be started in the center of the block. We don't want it at the center of the block. We want it to cover the entire block. So we need to subtract blocks z dot w, that's pulling the width of the block, and comma negative blocks z dot height divide by 2. Now you might say, why don't you just use width and HGT? Well, we might be putting all sorts of blocks into this array that are all sorts of sizes. So we need to pull that information out of the array. So we placed our image. Now all we need to do is pop, and that's almost everything. And we're getting an error. Let's see where our error is. H is not defined. Oh yes, I didn't call that HSB. It's hue pick. And then also we've got sat and BRT. So let's change that and try that again. There we go. Okay, so but you don't see the little circles. The reason is the p5play sprites are drawn at the end of the draw loop, and so they're covering up the sprites that we're replacing them with. So we need to make the p5play sprites invisible. We can do that by going to the blocks. We got this group. We're going to make all of the blocks invisible by doing this. Visible equals false. So let's try it again. There we go. We got rectangles with circles in the middle of it. And if we do it again, we get different colored rectangles with circles in the middle. But let's say we want different patterns in these rectangles. So let's do in the replace sprite, after we create our rectangle, instead of doing this circle as a pattern, we'll call a patterns function, and then we're going to create some patterns. Let's do that at the very bottom. And rather than go through that, all the detail of different kinds of patterns, I'm just going to copy some stuff. So let me copy and paste. If you want to know how to make patterns, I've got a video that goes over how to make simple patterns in P5.js. So you can look at that. Let's see. I've got to replace one thing. Oh, a couple of things. Darn it. Because I used HSB here and get color instead of make color. Let's find my hue pick, and let's replace all the hue picks with just an H. And let's replace the sat with an S, and let's replace the BRT with a B, and let's replace make color with get color. And I hope I'm not messing this all up. Hey, it works. Awesome. So now we've got different patterns on all these blocks. So let me just say a little bit about this patterns function, and there's a bunch of other functions that I dropped in here. First off, it's calling other functions. So if there's a pattern type number 0 through 1, it'll call a petals function, which draws one type of pattern. If it's between 1 and 2, it'll call a diamonds function, and if it's between 2 and 3, it just draws a circle. But the other thing to note is everything in here that has like a width or height is using CNV count. So you have to put that in front of everything in order to make your patterns. And then the other thing to note is that these patterns are being drawn based on the size of that buffer canvas. So we don't need to draw patterns that like fill the width of our screen space. We just need patterns that are going to cover that buffer canvas. This is going to work for rectangles, but let's say we make circles instead of rectangles. So if I change one of these scenes, this is the scene that's happening right now. If I change this from a rectangle to a circle just by doing this. I think that's going to work. Let's try it. So you can see with that rectangle right there, it's rotating weird because it's actually a circle. So if I make the blocks visible, I'll change this to true. You can see that there are p5play blocks covering up these rectangles. But let's make that false, and then, so if we go to our replace sprites, and we'll replace this rectangle with a circle. Let's just copy this. I'll comment out the rectangle. We'll say this is going to be a circle, and we don't need this. We just need width. So they're rotating a little oddly. Oh, I know what I'm doing wrong. I need this to be width divided by 2. There we go. Now they look normal, except that the patterns are outside of the circle. Did you notice that? See this one right here and this one over here? And the reason for that is that the patterns are filling the entire buffer canvas, not just the shape that we drew on the buffer canvas. In order for us to limit the pattern drawing only within the shape that we drew on the buffer canvas, we need to call a clip function. So this is going to be within the replace sprite function after we draw our shape, and before we draw the patterns, we want to call a clip function. I'm just going to copy this because it's a bit wordy. Copy, paste. So we do the canvas count, and then canvas.getContext2d.clip. I know it's a lot, but that is what you do to call a clip function. So that's going to limit the whatever is drawn next to within that circle or whatever this shape was that was immediately drawn prior. So let's hit play again. And now you can see that none of the pattern is going outside of the circle. One thing we can do if we want to have both rectangles and circles is we can have some sort of type in here. So in a replace sprite, if the shape type is less than 1, then we'll do a rectangle. Else, if shape type less than 2, then we'll do a circle. And then in our scenes, when we're creating our shapes, we can say that this is a shape type equal to 1.5 for this one, or actually 0.5 for this one, because we want this to be a rectangle in the spinning blocks. And then with the falling blocks, let's make those circles. Let's do 1.5 for circles. There we go. There's our circles. Instead of calling scene 1, let's call scene 2. Now it should do rectangles. There we go. And we got our spinning rectangles, and they've got patterns on them. So we could make additional scenes, we could make additional patterns, and we've already got all the code necessary to do that. So that's everything I wanted to show you with this project. You can check out my art project on FXHash to see the final result. If you've liked this video, please give it a like, consider subscribing to the channel, ring the bell for notifications, give me your comments. I love to read your comments. Thank you for watching. I'll see you in the next one. Bye now.